we're starting a new part of Module 4. Up until now, Module 4 has mostly been about multiplying fractions and decimals. Yes? But as you can see, today we're doing lesson 25, and your learning goal says I can divide. So we're changing now from talking about multiplication and moving more into division. Okay, and today you're going to be able to divide a whole number by a unit fraction. So let me give you an example. So Martha, give me a whole number. 5. And we're going to divide that by a unit fraction. Kazu, give me a unit fraction.
1 is 6.
Good. So there's an example, a whole number divided by a unit fraction. Okay, so today our wholes are always going to be whole numbers, and our divisors are always going to be unit fractions. Make sense? Okay, so this is an example. If I want to write a fraction as a decimal, all I need to do is rewrite that fraction, write a different form, write an equivalent fraction that has a power of 10. 10, 100, or 1,000 as the decimal, as the denominator, sorry. So 1/2 is the same as how many tenths? 5 tenths. Because I know in my numerators I multiply by 5 to get from 1 to 5, and so I have to also multiply by 5 in the denominators. So if I multiply 1/2 by 5 over 5, I get 5 tenths, right? Therefore, I can write it as 5 tenths. Does that make sense? Let's try it with the next example, 1/4. Can I change easily 4 to become some number of tenths? No, because 4 times 2 is 8, and I can't, right? But could I multiply by something to get to 100?
Yes.
What do I have to multiply 4 by to get to 100? Everyone? Can I just take 1/4 and multiply it by 25? Would that change its value? It would. But I can multiply it by a version of 1, couldn't I? What version of 1 should I multiply it by? Everyone? 25 over 25. So therefore, 1/4 is the same as 25 hundredths. Now that I have one of those multiples of 10, I have hundredths. How can I write 25 hundredths as a decimal? 0.25. Very good. These examples show that you can write a fraction as a decimal by changing it to an equivalent fraction that has a power of 10 as its denominator. Tenths, hundredths, or thousandths. Make sense? Good. Remember a long time ago when we first started talking about division, we talked about how division has 2 meanings. Okay, one meaning is sharing. If I want to share something equally, I use division to help me figure out how much each group will get. Another way is grouping. If I know that I have 5 groups, and in each group there are 5 people, that's division as well. Okay? So today we're going to be focusing on the grouping way of division. I'm going to show you what that means. I'm going to add on really quick. Grouping means like if I have a certain amount of stuff, let's say I have 30 students, and I want to put them into groups of 6 students in one group. How many groups will there be altogether?
5.
How'd you do that? Did you do 30 divided by 6 equals 5?
Yes.
But that's because I know how many people I want in each group. That's what it means by grouping. Okay? So today we're going to be talking about grouping. And Jenny with her pecans wants to group her pecans. I never know how to say that word. Okay, how many pounds of pecans does she have altogether?
2.
Okay, if Jenny has 2 pounds of pecans altogether, let's draw them. Here's 2 pounds of pecans. And she wants to put them in bags, okay? And in her first bag, she wants to put 2 pounds of pecans into each bag. How many bags can she make altogether?
1 bag.
Because she's going to put all of the pecans into one bag. The math equation here is 2 pounds divided by 2 pounds equals 1 bag. Okay, now in the second scenario, Jenny still has 2 pounds of pecans. Okay, but this time she wants to put 1 pound in each bag. So here's 1 bag, and here's the second bag, right? How many bags can she make altogether?
2.
2 bags, because there's 1 pound in each bag. Do you see that? The division equation is she has 2 pounds of pecans altogether, and she wants to put 1 pound in each bag. She wants to make them into 1 pound groups, and so altogether she can make 2 bags. Do you see that? Okay, now Jenny still has 2 pounds of pecans. Okay. This time she wants to put half a pound in each bag. So if I split it in half, how much is in each bag right now? 1. So here's 1/2, right? Here's half a pound, half a pound, half a pound, and half a pound. Do you agree? So how many bags can she make altogether?
4.
4. Let's think about what division equation we're writing this time. She has 2 pounds altogether, and she wants to put them into groups. How many pounds of pecans are in each group? How many pounds are in each group? 1/2. So we're dividing them into 1/2 size bags, and all together, how many bags can she make?
4.
So once again, she starts with 2 pounds of pecans. She wants to divide them into groups that are half a pound each, and in the end, we can see that she can make 4 bags. So again, we're seeing how many half-size portions, how many half-size groups she can make out of 2 pounds altogether. And how many can she make? 4 bags. Jenny still has 2 pounds of pecans. Let's draw that. 2 pounds of pecans. I split it in half. That's 1 pound there, right? Okay, now she wants to put 1/3 of a pound in each bag. So here's 1/3 of a pound. Here's another 1/3 of a pound. And here's another 1/3 of a pound, right? Over here, there's another 1/3, another 1/3, and one last 1/3. So this time, how many bags can she make?
6.
6. Because if I count them, 1, 2, 3, 4, 5, 6. There are 6 bags altogether. This time we're taking 2 pounds of pecans. We're dividing them into 1/3 size portions, and we can see all together we have 6 bags. Here, we are dividing a whole number, 2, by a unit fraction, 1/5, 1/4, 1/3, and then our quotient seems to be a whole number. We're finding out, when we do this division, we're finding out how many fraction-sized pieces I can fit into the entire whole that I have. Does that make sense? This problem says Tien wants to cut 1/4 foot long lengths. So he wants to cut wood that's 1/4 of a foot long, okay? Out of a board that is 5 feet long. How many boards can he cut? The first thing you need to do is write down what the question's asking and the important information. So Martha, what's the question asking us?
How many boards can be cut?
We want to find out how many boards can be cut. What important information do we need in order to figure out how many boards Tien can cut? Rashit?
He wants to cut them into 1/4 foot lengths.
Okay, 1/4 foot lengths.
And the board is 5 feet long.
Okay, so all together it seems like he has 5 feet of wood. Okay? And so you might want to show there's 1 foot, 2, 3, 4, and 5 feet, right? And does he want his whole board to be 5 feet long? What length is he looking for? 1/4. So in this first foot over here, how many 1/4 size pieces can he make? How many?
4.
So here's 1/4, here's 1/4, here's 1/4, and 1/4, right?
Mm-hmm.
In the next foot, how many 4th size pieces can he make?
4.
How many?
4.
Everyone, in this next foot right here, this is 1 foot, right? How many 4th size pieces can he make? 4. Okay, draw them. 1/4, 1/4, 1/4, 1/4. What about this third foot? How many 4th size pieces can he make? How many? 4. What about in the 4th foot? How many 4th size pieces can he make? 4. Okay, keep drawing them. What about in the last foot, the 5th foot? How many 4th size pieces can he split that one up into? 4. Okay, keep drawing them. Okay, so in the first foot, how many 4th size pieces did he make? 4. What about the second foot? What about the third foot? What about the 4th foot? What about the 5th foot? So all together, how many 4th size pieces can Tien cut? Because there's 4 here, 4 here, 4 here, 4 here, and 4 here. So all together, there are 20. If you count them up, you will see that there are 20 boards. Yes? The answer is 20 boards. Now let's talk about what math equation we did there. How much wood did we have all together? 5 feet. We want to divide them up into what sized pieces? 1/4. And so how many could we make all together? 20. So again, we're using pictures to show how we divide a whole number by a unit fraction to get the quotient. Another way we can think about this is to think about how many thirds there are in one whole. So how many thirds are there in one whole?
3.
There are 3 thirds in one whole. Okay, I agree. How many holes do we actually have?
2.
So how many thirds are there in 2 holes?
6.
Because I have 3 in one hole and 3 in a second hole, so then that's 6 altogether. Okay. How many fourths are there in one hole?
4.
So how many fourths are there in 2 holes?
8.
See how that works? How many fifths did I show that were in one hole?
5.
So how many fifths are there in 2 holes?
10.
Okay, very good. And that's what we're doing when we divide a whole number by a unit fraction. We're asking how many pieces, how many of those unit fractions can fit inside the whole. So how many sixths are there in one whole? 6. So how many sixths are there in 2 holes?
12.
Does that make sense? Okay, or if I do another one, if I have 7 divided by 1/8. How many eighths are there in one hole?
8.
Right, because if I have one hole, I divide it into eighths, I have 8 pieces. How many eighths do I have in 7 holes?
56.
56. And that's what we're doing today when we divide a whole number by a unit fraction. Okay, very good.